Systems of equations can be solved algebraically using methods of substitution, elimination, or we can apply matrices. But we can also solve systems of equations through graphing, which is what we'll look at doing in this section. In example 1, we have two different equations that tell us about the percentage of 18 to 20-year-olds who use alcohol, who are enrolled in college, and then that percentage for 18 to 20-year-olds who are not enrolled in college, where X represents our number of years after 2000. What we want to do is solve this system, so find where these two equations intersect, to determine when the percent of those enrolled in college and those not enrolled using alcohol will be equal. Switching over to Desmos, we can start graphing and simply enter the two equations that we're given. To enter the second equation, we'll click to open a new cell. And initially we don't see anything because our viewing window isn't set right. So using the plus and minus buttons, the wrench icon, or if your mouse has a scrolling feature, we can zoom in or out one way or another to find where those lines are intersecting with one another. And next we want to find that point of intersection. Desmos makes this very easy. If we click on a line, what we're going to see are a couple of points pop up in gray, which will quickly give us important pieces of information, like here, the y-intercept. Or here, what we're interested in is the point of intersection between those two lines. So in this case, that occurs at 25.923, comma 11.224. What we're interested in is, when the percent of these two groups will be equal. So what we want is that value for X, the year. So if our two graphs are intersecting at 25.923, comma 11.224, that tells us that the year in which those percents will be equal will be this 25.923, which represents years after 2000. So in approximately the year 2026, the percentages will be equal. So in order to use Desmos to solve systems, that's really all we need to do. Graph those two equations, and then use Desmos to identify that point of intersection. In example 2, we're given a revenue and a cost equation, and what we're asked to find is the break-even point for this given product. A break-even point is when revenue and costs are equal. So we can go back and delete what we already typed in by clicking these X's over in the corner and type in our two new equations, R equals 16.5 times X and C equals 14X plus 350. Again, what we're looking for is the point of intersection because we want our revenue to be equal to our cost. So we can zoom out until we start to see these two lines, and try to zoom back in to find that point of intersection. What's nice about Desmos is we don't have to be too precise, because if we click on either of those lines, it's going to highlight that point of intersection for us, which it looks like is occurring at 140, comma 2310. What we're interested in is the production level, which is that value for X. So what we could say is at a production level of 140 units, our revenue will equal our cost, which is the same thing as that idea of a break-even point. In example 3, we're told the demand for a certain product is given by our first equation. And the supply is given by the second equation, where P is price and Q is the number of products. We want to find the price at which the quantity demanded equals the quantity supplied, and we want to find that equilibrium quantity. What's a little bit different here is that we will need to rewrite these two equations in terms of x and y. It doesn't matter which variable is which, as long as we're consistent between those two equations. So the first equation we'll rewrite as x plus 3y, and the second equation we'll rewrite as x minus 2y. Another thing that's nice about using Desmos is we don't have to rewrite our equations in terms of a y equals statement. We can type these equations in exactly as they're given to us, or exactly as we've rewritten them, with x and y both on the same side. And it will still graph those functions for us and let us identify that point of intersection. So in this case, that would be the point 250, 30. So at a price point of $250, since our value for x replaced our value for p, that's our price point, we'll reach the equilibrium quantity of 30 units. So in each of these cases where our equations are given to us, we can simply plug those into Desmos. In the case of this third example, we replace our variables with x and y, but we simply type in those equations and find those points of intersection.